Hi everybody, and welcome to the hands-on lab on machine learning agents. If you want to follow along during the lab, there are USB sticks that are being passed around that contains these very precious files that you will need if you want to be able to play along with us. So for Windows 10, you will need Anaconda. You will need the package, the machine learning agent package that you can also download at this address. You will need the TensorFlow Sharp plugin if you want to be able to run your neural networks inside of your games. To do that, I will show in a minute how to download it from the internet, but it's included in the USB sticks that are being passed around. You will also need to have Unity 2017.2 or above, so we have on the stick the installer for 2018.1. If you're on Mac, you will need to have Python, and similarly, you will need to have machine learning agents, the package. You will need the TensorFlow Sharp plugin, and you will need a Unity version above 2017.2. Now, let's get started with the lab. So for those of you who were not at the presentation this morning, let's go very quickly over what are agents and what they can do. Agents are the things that you put in your game that use observations in their environment to take actions. They're actors in the environment. You can use agents for multiple things. So we have examples of agents that play as the player, so they play with the point of view of the player that you can use to test your game, to have the agent try to play your game and solve it. You can have NPCs, you can have non-player agents that can be things that will oppose the player or will play along with him. And you can have also invisible agents. These agents manage things in the game. They are in charge of certain parameters, and they use observations about the player to adapt to the content of the game depending on the type of player you have. To train these agents, we have two different methods. We have reinforcement learning and imitation learning. With reinforcement learning, what you do is that you reward the agents when it does certain things, and you try to orient the behavior of the agent with these rewards. So this means that the agent just tries a bunch of things, and when it gets rewarded, it will try to do more of these things again in the future. And that can give you superhuman abilities because the agent is not constrained by a human. Because a human is not interacting with the agent at all while the agent is learning, it can grow to be maybe stronger than a human. So the way this works is through observations, actions, and rewards. So when the agent is in state, it will collect an observation about the state, will act in the environment, and depending on the consequences of this action, will get a reward or not. And you use this reward to shape the behavior of the agent. So we've seen this video of the little chicken crossing the road. The agent sees the image, and the agent is able to learn to collect presents and avoid cars by moving. So the actions are basically moving into a grid. So we'll look at the video here. This is before training. The agent just got started, so it's exploring very randomly. That hasn't picked up presents or being hit by cars yet, so it doesn't really know that it's good to get presents and bad to be hit by cars. But after a while, the agent starts to get it. He's using the rewards to change its policy and learns to solve this problem. So here it's just after an hour of training, so it's not very good. It's still looks like he knows that getting the presents is good because it looks like he's trying to get as many as possible, but still is not very good at it. And it gets hit by cars. And after 6 hours, the agent is a superhuman, just getting as many presents as possible, and he's going very fast through the level while not being hit by cars at all. The second, so we'll train an environment like that. It's going to be the balance ball, so the platform trying to balance the ball. The reason we choose this environment is because it's very easy to train. It doesn't take long, so you can really see the learning right in front of your eyes. The second method we will be looking into is imitation learning. With imitation learning, you provide demonstrations to the agent, and the agent tries to imitate what you're doing. And this will give you human-like abilities, because since the agents try to imitate what you're doing, then it will look like it's a human playing. This is the demonstration with Antigravity. On the left is the human, and on the right is the agent. And so at first the player knows how to play the game, so he turns right at the right moment and turns left at the right moment. It knows when to accelerate and when to decelerate. And the agent is learning from this player. So at first it keeps hitting the wall because it doesn't know when to turn, when to do what. And every time the player does something, every time the player reacts to the environment, the agent learns from that. So it's gradually getting better and better. And after 30 seconds, you can see that the agent is already taking the turns quite well. It knows when to turn. And this, right after that, this is after just 5 minutes of training. So this can be very fast because the agent doesn't need to learn from rewards. It can just learn from demonstrations. So it's easier for it to learn. And you can see that they are roughly doing the same thing on this track. The agent is able to, would be able to provide some kind of challenge to the player if it was embedded into the game. So we're going to see these two different methods in this tutorial. And let's get started right now. First, we will try to get the things installed for you. So if you are using a Windows computer, you should have all of these. So you should have, okay, so you should have Unity 2017.2 or above. You should have Anaconda, machine learning agents, and the TensorFlow Sharp plugin. If you want to use the GPU, you can install CUDA or CUDA-NN. For the sake of this hands-on lab, you only need to have the CPU. So to get started, you need to run Anaconda. Run this command, conda create -n ML agents with Python 3.6. This will create an environment in which you will be able to use TensorFlow, in which you will be able to use Python to train your agents. Then you must activate this environment. You need to go into it. So you call activate ML agents. ML agents here is the name of the environment you created with Anaconda. You see on the line above, you created -n ML-agents. This is the name of your environment. And once you're into this environment, you can start installing the TensorFlow and all the library, the packages necessary to do the training. So this is with pip. You run pip install the TensorFlow version. We use version 1.7.1 to make sure that everyone has the same version. You need to see these. This is to go into the directory. The directory you just installed. So when you have the ML agents folder, the one that you download from the GitHub repo or that you have on the USB stick, you can go into this Python folder that's inside of ML agents, and then from there you run pip install dot. So there needs to be a space between pip and install, and also a space between install and dot. This is so that, that we have a file inside of the Python folder that contains the list of the libraries that will be automatically installed with this command. Do not forget the dot, because it is not going to work if you forget it. Similarly, on Mac OS, you will need Unity 2017.2. You will need to have Python 3, so we have Python 3 into the USB stick if you want to use it. Same, you will need the exact same machine learning agents package and the TensorFlow Sharp support if you want to be able to run your neural networks inside of your Unity game. The procedure to install to get started and installing the libraries is very similar. You need to have Python 3. You need to do pip install TensorFlow 1.7.1. Then you must, identically, just the same as Windows, you must go into the directory, into the ML agents folder, into Python, and then call pip install dot, and this will get you the appropriate library so that you can start the training with us. So this is just to summarize here while we can get started on the training. But first, if you want to install your packages directly from the website, I'm going to show you real quick. Am I even on the right? No, this is not the right display. Okay, so this is the website under which the repository is. So it's Unity Technologies /ML Agents on GitHub. If you want to install the package, you download it here. You can download it as a zip here. And the TensorFlow Sharp plugin is located into the documentation. So you can go into the documentation. It's here under creating learning environments, the TensorFlow Sharp in Unity. So this is where the plugin lives. And you can download it here into requirements, the TensorFlow Sharp plugin, download it here. So this will start the downloading of the Unity package containing the plugin necessary to run your neural networks inside of your game. Now, if you have all that, if you open Unity onto so if you look at the repository, this is into ML agents. You have this folder here. So this is the Python folder. And this is the Unity environment folder. This contains the assets folder. So you can open it directly with your version of Unity. And when you do so, this is what you get. This is the assets folder. So it contains ML agents. And here the example projects and some scripts that we need to. So this contains the agents, the academy. Let's get a refresh. I'm going to remove all these agents for simplicity. These are two new elements into this scene that are not here by default when you create a new scene. It's this ball academy here. The academy is responsible for handling the training of the environment, and then you have here an agent. Let's get started with what's inside of the agent. The game here, it's this component. I'm going to open the scene. This is these game objects here. It's in game 1.1. It contains a platform and a ball. And the platform is the agent. So you can see here it has a script, the ball 3D agent, that is attached. It has also the ball associated to it. We'll look deeper into the script later. This example is located in the examples, ball 3D. It's the first one here. In examples, it's ball 3D, and it's this one. It's this scene. So if you want to open it to play with it right now. What we must do with our agent now, if you remember how an agent works, it collects observations from the outside and it performs actions into the environment. So now we need to define this platform, this agent, what it's collecting about the environment and what it needs to do in this environment. So let's look into it. We have here the ball3D agent script. And when I open it, we have a few methods for initialization. This is the interesting method. This is to collect observation. We use the addVectorObs method to add the rotation of the platform. This is the transform of the platform, its rotation under the z-axis, the rotation under the x-axis. We add the displacement of the ball, so it's the position of the ball, and you subtract the position of the platform to get the relative position of the ball with the platform. And you also add the velocity of the ball. So this defines the set of observations for your ball. For your platform, what the platform agent needs to know about the environment. And then you have the agent action. So this vector of action is what the model, the neural network, will give to your agent. And you must define now what this agent must do with these numbers, with these actions. So here what we say is that the agent must rotate according to the first number in the z direction and according to the second number in the x direction. This means that the network will give two floats. The first one will correspond to rotating under this axis, and the second one will be rotating with this axis. Then what we do is what this if condition is for here. This defines that if the ball gets below the platform, or if it gets too far from the platform, then you must set your agent to done. This means the agent failed. The ball failed, so the agent is done, it's over, and you give it a penalty. You say this was a bad behavior, you drop the ball, this is not acceptable. And if the agent did not drop the ball, so if it's maintained, if it keeps playing the game, you can add a reward, you add a 0.1 reward for the agent. Now, about orchestrating all of this, you need to have a game object into your scene that contains the academy. The academy is used to manage the training session. So here you have training configurations and inference configurations. This determined how much faster you want your training to go compared to your inference, so compared to playing the game at normal speed. So you can see here that the time scale, I set it to 20, so that when we do the training, the simulation will run 20 times faster, so that you don't have to sit and just watch the agent drop the ball in real speed. It will go a lot faster to make the training easier. Then what we do is that we have this brain component, so it must be a child of the academy. So you create a game object and you add this brain component here. Into this brain component, you must define what is the input, the observations your agents will be looking at, so how many of them they are. So here in this example, there are 8. Because remember, we add the rotation in the x-axis, that's 1. The rotation in the z-axis of the platform, that's 2. We add the displacement of the ball in 3 dimensions. There is x, y, z, so we're at 5. And then you add the velocity of the ball, x, y, z, so that gives you 8. And the number of actions that the platform network will give to the platform will be 2. There will be the rotation in this axis and the rotation in this axis. That will be 2 actions. You can set up different types of brains, so we have 4 of them. We have the player brain. The player brain is when you want to take control over the agent, you want to play for yourself. So for example, here I set what keys correspond to what into the scene. So here we have 4 keys. We have the up arrow corresponds to changing the first number. The down arrow corresponds to changing the second number. So now if I try to play the game, I will be controlling it with my keyboard. So when I press the buttons, I can move like left, right, left. And I can try to, well, I'm doing a terrible job at it. So yeah, you can control the platform and to try to maintain the ball on top of yourself. The second one is heuristic. With heuristic, you can create a script and basically mimic what the brain will be doing. So you can take in the observations that the platform has and create via script the actions you want to set. That's very useful for debugging so that you can know, like, oh, can a simple script, can a simple heuristic be able to solve the game, take some decisions? Does it look like something already with a script? This is used also to compare how well an agent can perform if you had to code the entire behavior yourself. Then comes the external brain. So with the external brain, we'll be able to connect with Python in order to run the training. So when I set my brain to external, it basically means that when the agent collects an observation, it will send it, Unity will collect these observations and send them to Python, and Python will take the decision using a neural network, using TensorFlow, and then send back the action into Unity for the agent to act. And this will allow Python and TensorFlow to create this policy to optimize the number of rewards that the agent collects. So in this scene, right now I have just one agent, I just have this one. But what I can do is that I can create a lot more of them. I'll have 12 here. This, by having multiple agents into the scene, I can make kind of a parallel training. Having more agents means that I can collect more data, and I will eventually run my training faster because I have more agents to control, and they'll be in different situations at different time. So I can learn a wider variety of things from the environment. Now let's get started with the training. So I just opened my terminal here, and this is where I am. I am into my ML agents folder. And from them, I want to do a training session in the editor. So what I do is that I need to call Python 3. This is the program we use to do the training. There is a script we have in the Python folder called learn.py. And this is the Go script. This is the script you need to call in order to be able to train your agents. Then the only thing is that I need to specify that I want to do a training session. So I pass the argument, hey, I want to train now. And since I'm running into the editor, I can just run this command and I will connect with the Unity editor. Remember that you must have your brain here set to external so that Python will know that, oh, I need to take control over this brain and try to train it. So I just run this command, and after a moment, when everything gets started, I'll have here this message saying, to start training, press the play button in the editor. So this means that now that everything is ready, I press play, and I can start my learning session. So this is going at 20 times speed, but if you can make something out of it, you will see that the platforms are doing a terrible job. They are dropping the ball everywhere. They just started training. They don't really know what to do, so they try a few things. And you can see that the reward they get is just 1.2 right now. But they are learning. Every time the ball gets dropped, every time the platform does something bad, you get a penalty. And for as long as the platform maintains the ball, it will get rewarded. So the platform will eventually figure out that, oh, if I move this way when the ball is there, then I start getting more rewards. This is what I should be doing. This is what I'll keep doing. On the right here, you can see that the cumulative reward, so the amount, it corresponds here in the simulation to the amount of time that the platform are able to maintain the ball. You can see that it's increasing with time. And if you look down there, you can see that the platforms are actually starting to do something. They're starting to maintain the ball a little bit longer than they used to when they were just doing random things, when they didn't really know what to do. And now you can see that it starts to look quite good already. They keep dropping it. It's not very good. But you can see that the rewards are already at 7, so they're doing 7 times better than random. If you look at what's going on in my editor window now, they start to look very good. They don't drop it that much anymore. You can see sometimes that the window freezes a little bit, like it stops for half a second. That is because this corresponds to the network doing an update. So the simulation stops a little bit in order for the network to update the policy. And wow, the reward is already at 76, and the agents basically learned how to balance the ball here. I'm going to stop the training now, so I can just press pause in the editor here. And here, this guy tells me that I interrupted the training. Yes, that's what I did. And I generated a graph here. So let's look at where the graph is. I created here models, PPO. This is what I run. This is the default name of the folder here. And I forgot to clean what was here, but basically this is the file that got created. This is the ppo.bytes file. So then what I can do is that I can take this file here and I can drag it into my Unity project explorer here and put it here. So this is a model that was previously trained with the 3D ball. And then what I can do is that I can set this brain here to internal. If I set the brain to internal like that, it will tell me, oh, you do not have the TensorFlow Sharp plugin. So you cannot run it. But I installed the plugin, so the way I did that is that I just imported my custom package and I imported the TensorFlow Sharp plugin package that was on the USB stick or that you then downloaded from the internet. So now I have the package. I have the package into my Unity. It is right here. It's in my plugin. This is all of these files that are needed to run your neural networks inside of Unity. So now what I must do is that I must enable Unity to use this plugin. So to do this, I'll go into my project settings, into the player, and then we'll pass a new compilation flag here. Scripting defined symbols, I will say I want to enable TensorFlow. And I spelled it right, I think. And this will basically tell to use the libraries so that I can run my neural network. So now if I click on the brain, you can see that the error message disappears, and then I can drag my ball model right here. And these are automatically pre-filled with the default values that you have when you train. So these are completely unchanged. These are the default values. And now if I play, you'll notice I don't need to connect to Python anymore. It's not really a training session. I'm also running a lot slower. This is running at the normal speed. Remember, the training was 20 times faster. So this is now at normal speed, and you can see that the platforms are doing a very good job because this is with a fully trained model. The what? Yes, okay. So if you have installed your plugin, how do you do this enable TensorFlow thing? Let's go over this again. Because installing the plugin is not enough. You must go into Edit, Project Settings, Player. And this will open the player settings for the current platform you're building on. So here right now I'm targeting OS X. So here it will open this the player settings for OS X. I have here iOS and Android. If I wanted to build for iOS or Android, I would need to enable the same. I would need to write enable TensorFlow into all of these different platforms. And I just added here, enable TensorFlow. Don't forget to press enter because just typing it is probably not enough. You need to type it, press enter so that it's registered and it starts recompiling the scripts. This is how you do reinforcement learning with the balance ball. We have other environments to show other features, but now, unless there are some questions about how to do reinforcement learning, I'll go next over imitation learning. You had a question? Sorry, can you repeat that? Yes. Yes, we used add reward in the, so you're talking about the balancing ball agent script. Here, this is the agent, and we say here set reward and set reward. We have another method that is add reward, and that is if you want, if, for example, the agent could do something, concurrently do something that would give it a certain type of reward and doing something that would give it another type of reward. I could imagine something like the agent being rewarded at every step it's in the air, for example, and getting another reward if it's above something good, like if it's above a certain goal. And when you do this, you would have two reward signals. You would have I'm in the air and I am on top of this goal. So you cannot use set reward here because this would mean that only the latest reward is being calculated for this step. So you would probably use add rewards that you have the sum of the two. These rewards here are just for that particular step, just for that particular action. The agent is trying to accumulate rewards. So for each, the agent will just say like, for this step, I got this amount of reward. And then you will try to maximize the total number among all of the steps, the accumulation, the total of all of the rewards. So in this example, it doesn't matter because for every action, you only ever add one. So it's the same with set and add. It's exactly the same in this example. If you are wondering also about what this method does, it's when the agent is set to done, you must specify what happens next. If the platform drops the ball, you must be able to say, hey, okay, you dropped it. You need to reset so that you can keep learning. So this basically just means randomize the position of the platform, reset the platform, and then teleport the ball back on top of the platform so that you can keep playing with it and learn. Any other questions on this reinforcement? Yes? If you go in, so even though you typed enable TensorFlow into the player settings, you still have the same error popping up? The error that says you need to enable the TensorFlow Sharp plugin? Okay, is this the error that was appearing here? Is it an error in the console or is it an error here? So this probably means that you do not have the TensorFlow Sharp plugin. Remember, you need to install the package and use the asset, import package, import the custom package, and import the TensorFlow Sharp package this way here. Now let's look at imitation. Sorry, another one. So to how to design the appropriate reward function. The reward function you define will guide the agent into its learning. So in this scenario, any set of reward that would kind of make sure that the agent is rewarded for keeping the ball on top and penalized when dropping the ball would lead to similar results. The way you shape your reward, there is not one way that fits all, because it really depends on the problem you want to create, what you want your agent to do. And if I had set the reward of the platform inverse, if I said like you lose points every time you have this ball on top of you, the platform would learn something like move as fast as possible to shake the ball off. So with best practices, you will probably get a faster learning, a more guided learning if you add rewards frequently, if you have dense rewards. But you would probably not, but you don't want to guide your agent too much, because then it would be really you're kind of over-engineering what your agent must do. So there is a trade-off between doing everything for your agent, really setting everything it must do, and let him kind of learn from just, you solved the problem, you did not solve the problem, +1, -1. This is the simplest way to make rewards. All right, now on to imitation learning. So we have one environment that we use to show imitation learning, that is the banana collector. So it's this one. And you have here banana IL, so it's short for imitation learning. So if I open this scene, this is already set up with my agent here. The one with the hat is the one I can control. This is the teaching area, so this is just this area here. And it will contain a teacher agent. So this is the one I will be controlling. It is the teacher, the one that is showing demonstrations of what to do to the students. And then we have 4 student agents. These students are the one that will learn from the player. We have here the teacher agent. You will notice he has a teacher brain, while the other students here have a student brain here. This is where you link for the agent what brain it needs to have. So here for the student agent, I just dragged I have 2 brains here. I have my teacher brain, and I have my student brain. So for a student, I'll drag my student brain right here. Oops. I put it back, sorry. No, not here. Okay. Put it right back. If you don't put the brain, so you probably saw that if I don't put the brain under the academy, you'll have an error saying that the brain must be a child of the academy. That is because we need the academy to know what are the brains that need to be looked at. So here my teacher brain is controlled by the player. It is in player mode. This means that I will be the one controlling the teacher, while the student's brain is being controlled by external. That is because we want it to learn. We want the students to learn from the player. In order to launch an imitation learning session, you will need to tweak the training parameters. So the training parameters are set in here inside of the Python folder. I don't think I opened the right one. I should have opened my Unity environment here. It's this one. No, it's not this one, not even. I want to open this one, the Python folder. This is the one that contains this file, the trainer configuration, trainerconfiguration.yaml. This is where the training parameters here are defined. So we have a set of default training parameters. So the default is to use reinforcement learning. We use PPO. PPO is the name of the reinforcement learning algorithm we use. These are all the default parameters, and for the balance ball, for example, in the previous example, I was overriding some of these training parameters with these. I was changing some of these parameters. If you want a description of what all these parameters can do, there is a nice file on GitHub that will tell you into the docs. Training with training with PPO, proximal policy optimization. This will give you here your hyperparameters, so what they correspond to. So you can change their value if you want to tweak around the learning of the agents. If you want to do imitation learning, what you will need to add is something to your student's brain. The student's brain here, remember this is the name of the brain in the imitation learning scene. We can define here what is the brain you want to imitate. Here it is the teacher brain that is also in the scene. So when I set this here, this will mean that when I launch a training session, I will use imitation, and I will try to imitate what the teacher is doing. So let's look at what it does here. I have my scene set up, everything is ready. So now I can run the same command. The same command, I will run imitation learning because I changed my training parameters here. So when I run this command this time, I get this. Again, play with the editor. So I can start playing here. Something wrong happened. It's going a little bit fast here. That is because I set up my training speed to be too fast. So what I can do is that I can run the same command but pass in slow here. This will slow down the simulation to allow me to be able to provide inputs to the agents because I cannot think as fast as they do. So I just run this again. But this time it's in slow mode. So now I can see what is going on. So I can control this agent here, and I will try to get to the good bananas, to the bananas that are not blue, only to the yellow bananas. I'm exploring around, getting bananas. And if you look on the right, you can see the other agents. So the one in black is the one with the hat, so it's the one I'm controlling. And the other agents here are in blue. And you can see that they're kind of still just looking around. They don't really know what I'm doing, what I'm trying to achieve. But they understand at some point that I'm going to try to get only to the yellow bananas. You can see a score at the bottom that does not correspond to my score. It actually corresponds to the score of the agents, the students. And if I keep getting the bananas of the right color, they will eventually figure out to do the same thing. So now I will turn off recording. And you can see on this side here, the agents are moving around. They are moving, exploring what I'm doing. I'm going to clear the buffer. And if I do something, for example, look at me here, I'm just running into a circle. I'm just turning around. I'm just spinning on the right. Just spinning, just spinning. You can see on the right that the other agents, the blue ones, are starting to do the same thing. They're starting to always just turn on the right. If I clear my buffer and I decide this time that I'm just going to go forward all the time, oh, I cannot exit here. But let's see now, I want to go always just backward, like this. You can see that the agents will eventually do the same. They try to go backwards all the time. They look at this one, is doing out. It's going backwards. It's trying to do exactly what I was doing a little bit earlier. They're imitating what I'm doing. Now I can stop my training, and in the same way, you will have your reinforcement learning models that is fully trained that you can take and put back into the game the same way. Yes, this is roughly how you would want to train for reinforcement learning and imitation learning. We have, so I'm going to talk a little bit about this new feature we have that is called Curiosity. And to look into Curiosity, you can look at this one, the pyramids environment with reinforcement learning. So the goal here in this environment, I am going to play as the agent. So this is me controlling it right now. So up, I can explore this environment here. And what I must do, the goal of this game is to find this switch, press it. You can see that the pyramid just only now appears. I must take this pyramid down, then push around the push around until I can get to, come on, it's not that hard. So I can get to the brick. And only then I won the level. Only then I won the game. So this is extremely sparse. You don't get a lot of rewards here, only when you get to the final goal. So this means that you need to put some kind of rewards along the way to help the agent. And this is what curiosity, that's what it does. It kind of puts reward along the way, and these rewards are determined by how much the agent is going to be surprised by what happens in the environment. So when the agent starts doing random things, maybe at some point it will press the button, and then it will see a new pyramid. And I have never seen this pyramid before. I do not understand. Why is this here? This didn't happen before when I was just exploring. This means that pressing this button led to new things that I did not understand, and that's surprising. So the agent then will be rewarded for having found this new thing, this source of surprise, and then since it got rewarded, it will try to do that over and over again until it fully understands the way it works. And by doing this, the agent will then explore a lot better its environment and eventually get to the golden brick more often. And by getting to the brick more often, you will get more rewards and will be able to shape its policy better. You will know what is being rewarded, that it's the brick. And in order to get to the brick, you must press the switch, topple the pyramid, and get to the gold. So the way you would want to do this, you would want to use the same YAML file, but you can see here in the default, you have this use curiosity flag that is set to false by default. So if you want to enable curiosity into the pyramid environment, so where you have the pyramid brain, this brain here, you enable curiosity to be true. And you must also set how much curiosity you would want to have. You don't want to have too much curiosity into your environment, because if it's too high, this means that the agent will just be concerned about exploring, just trying to understand the world, and it will not even grant any importance to solving the problem. So we'll just be happy with finding new things that are exciting to it and just explore like this. And that's probably not what you want. You don't want an agent that understands the world. You want the agent to be able to solve the problem you gave it. And that's why you use rewards, because you want the agent to use these rewards. This use curiosity flag works the same with to enable memory. This is a very similar way as when you want to enable memories into your agent. And with memories, your agent will be able to remember things that they've seen before. So this is in the environment called the hallway. You've seen this environment from the talk. The agent here, the goal is to go to the gate of the right color by looking at the block first and then getting to the appropriate gate. This means that if I remove the block, the agent will just not be able to find it. The agent will remember to look at the block and remember the color of it to get to the right gate. We have all the environments I talked during the info session. You have all these scenes here, the soccer brain. You have the soccer scene. Pyramid, we have locomotion environments. So if you were interested in the way we ran the Good Boy demonstration, the closest environment we have in the repository right now is the crawler with a target. So in this environment, you have this little cute spider, well, this crawler that controls directly the limbs with the neural network. This means that the observation the crawler gets here is its orientation in space, and the action is adding torques to the legs to move around. And the agent learns to use this, to use its leg in order to walk, to crawl towards the goal. Are there any questions about these environments here, or about reinforcement learning and imitation learning? All right, then I think that will be all for now. Thank you very much.